video, we will discuss about abstract factory design pattern. Okay. To understand this design pattern in detail, you will need some understanding of factory design pattern. So either watch my video of factory design pattern or come here by getting some understanding of factory design pattern. Okay. So we have seen a factory design pattern, right? So what happens in a factory design pattern? Basically, it will produces the products, right? So a factory method or a factory class is nothing but which gives you products. This was the UML diagram that we have seen. So here these UML arrows and all are not proper. Just take it with a pinch of salt. So in the factory method, what happens is you will define an interface, okay, and then you will have your concrete factories extend that interface, and those will give you the product. So if you see here, you have this diagram, you have a creator, and then you have this factory method, okay. Now what happens is your factories, all these concrete creators or the factories, right? So these factories, it will implement this factory method, and then it will give the products. So the example we have seen is, let's say you have a pizza method, like you have different styles of pizza, and then you create an abstract method in the main class, like in the super class, and then your child classes or the concrete factories will provide implementation according to their style. Like for pizza, we have this New York style and the Chicago style. And even if it is a car also, you will have the factories related to the brands. Okay. So here what is happening? Basically, your concrete factories are giving one product, or they are actually creating a product. Okay. Now let us assume a scenario. Okay. Now initially you let us assume a furniture example. Now initially this furniture firm, it was providing only chairs, it was manufacturing the chairs, okay. Now what you have done, you have created a factory, and even under the chairs you will have different varieties of chairs. Like few are the wooden chairs, few are the plastic chairs, and few are designed according to the more old style, and few are designed according to the modern style, right? So there could be different kinds of chairs, okay? But your factory method, like here you can assume this as a furniture firm, and then you have a factory method that will produces the chairs, okay? Maybe you will have multiple factories according to the styles. Like one could be the modern, this concrete factory can provide modern chairs, and this can provide the old chairs, and this can provide the wooden ones, and this can provide the plastic ones, okay? Now let us assume your furniture firm wants to add more varieties of products. Okay, it wants to manufacture sofas, and it wants to manufacture tables, teapoys. Okay, now in this case, okay, now let us assume since it is expanding its business and it is manufacturing different kinds of products, okay. So to get that product, what you will think? You will think that, okay, for chair, I have followed the factory method pattern, and then I left the creation part or instantiation part to the concrete factories, okay. Now I can do the same way for other products as well. Like for sofas, for tables also, what I'll do is, maybe I'll create one more super class, and I'll have my concrete factories which will instantiate. So let us suppose you have a factory method for since we have already done for the chairs, maybe for sofas, okay. For sofas you have other product, like you have other concrete factories, okay. And along with that, you will have a product, like already you have a super class product and you have child classes, right? Here it would be the super class chair, and these are the varieties of chairs. In the same way, you can have a super class sofa, and then you can have the multiple varieties of sofas, okay. Now what you have done is, you have created another factory method in a separate class, and then you have your child concrete factories doing that implementation, okay. Now well and good. Now in future, what they want to do is, they want to add a table as well. Like you have sofas, and you put a table in front of the sofa, right? So what they want is, okay, I'm providing chairs and sofas to my customers. They want a table also so that they can put books or coffee cups, anything. Okay. Now what you will do, okay, I'll create one more product class. Okay, this is the table is my super class, and child classes, like be it a plastic chair or a wooden chair, or the chair is manufactured according to the modern architecture or the old architecture. So you have different kinds of tables as well. Okay. Now what you will do to get an implementation for these tables, you will follow the same. You will create another class and declare an abstract factory method, and then you will have your child concrete factories. Okay. And then these factories will instantiate it. But is this the right approach? Like whenever a new product is introduced, you are creating multiple factories. And let us assume you have one more scenario. Okay. Now when a person is ordering, like let's say I went to furniture firm and then I have added, I want to take a sofa, and then along with the sofa I'll buy a table. Now I should make sure that, or the furniture firm should make sure that, like let's say I order a wooden table or wooden sofa. So I order a wooden sofa, and the table also should be of wooden one, right? No one takes wooden sofas and then they will take the plastic tables, no, right? So they will take everything the same one, uniform one. Like for the furniture, if they are preferring the old architecture sofa, they would also prefer a table of old architecture, not the new architecture, right? So there is some relationship between the products. Like if you are going, if you are creating one product, then the other product also should be of a similar one, should be of a similar style. So here if you create different factories, and when a customer comes and says that I need I need a old model sofa, then this factory will give you the old model. Now the customer can ask for the plastic one here, or the person in the furniture firm, he can give an he can give a plastic one. Here he has given the old model or old architecture sofa, and here he is giving the plastic one. So these are not clubbed together. Like there are chances of giving non-related products here. Okay. Because there is no restriction you have put here. Like anyone can come and take the modern architecture sofa, and then he can go for, like the furniture firm can go and give the plastic table, which is not appropriate for this scenario, right? So like whenever a person comes and asks you sofa, like let's say he takes the wooden sofa, and the other products also should be of the similar one. So what we will do is we will group. Okay, we will group whatever we need. So here, so I have already a factory method for the sofa. Now I'll add another factory method for well, another factory method for chair as well. So you will have a sofa, chair, and the table of similar kind. Okay. So now I'll add a three methods. Okay, three factory methods. One factory method produces the chairs, and I'll add another factory method which produces the sofa. I'll add another factory method which produces the table. Okay. Now, like it here, you don't have any concrete implementation. It can be of any kind. Okay, it can be plastic one, wooden one, or the modern one, any one. But the concrete is okay. Like how you have a concrete factory or the concrete creator in the factory method, you have a concrete factory as well here. Now here it was implement. It has method. It was providing logic to create only one product, like let's suppose chain. Now it will provide implementation for the other products as well, because you have added two more factory methods in the creator class. So when you add two more methods here, it has to provide the implementation for those methods as well, because it is extending that, right? So here you will create sofa, and then here it will create the table. Initially it was creating only the chair. So now if you see the one, okay. So this factory will provide all products which are made of food. and you will have another factory related to the plastic. Here also you will have three factories, okay, chair, sofa and the table. So what it does is it will provide the plastic chair, it will provide the plastic sofa, and it will provide the plastic table. Likewise, you will have modern architecture, chair, sofa factory. So what you are doing basically is you are creating a concrete classes or the concrete factories which is providing implementation that would be, that would stay common for all the products. Okay, now let us consider another example. Okay, now let's say you take a phone or any iPhone or OnePlus. Now you should buy a charger of iPhone. Plus charger don't fit for iPhone, right? Okay, and there are other accessories as well which fits only for the iPhone, not for the OnePlus. Like you can't use this OnePlus cover or OnePlus charger to your iPhone. So in this case, what happens is, let's say your creator class is giving you an iPhone. You should have your accessory methods also. Okay, so those should be grouped, even the charger, the cable, or even the cover. So these things should be grouped together. Okay, you can't club all the product combinations. So there exists, like even though you have multiple products, the combination should fit, right? Like as I have said for the phone example, maybe one factory method it will give you the phone, and another factory method it will give you the charger. Okay, now this operation what it will do is maybe it will club both the phone and the charger. So your concrete factory, what you will do, maybe let's say iPhone concrete creator, it will give you method for the phone and it will give you the charger also. So the charger, whatever it gives, it fits for this particular product. Example of that. And another example, if I say, let's say you are creating an application specific, you are creating an application. Okay, now while you are deploying it, you have multiple OS, like you have Windows, you have Mac OS, and say let's say your application has multiple buttons. You are creating an UI application. Okay, in the UI application you will have buttons like checkbox, dialog and all. So the application, how it works, the operation and all could be same, but the products it uses are different, right? For Mac, the button or the dialog will be different, and when you are creating, when you're creating a dialog is different for Mac and the Windows. And in the dialog you'll have a button, okay, cancel, that will be different for Mac and the Windows. So all these button, dialog, checkbox, this combination is different for Windows application and it is Mac OS application. So what you can do is you can define factory methods for each button, dialog and all here, and you can have Mac OS creator, and then you can have Windows concrete creator. In Windows factory it will provide only Windows related buttons, and the Mac OS will provide only the Mac OS related buttons. And even you can take another example as well. Let's say you're manufacturing a laptop. Okay, so depends on the brand or the type of laptop you are preparing. So along with the laptop you will have the hard disk, motherboard, so other accessories also. Maybe if you are going for the Mac, those could be different, or if you are going for the general Lenovo kind of thing, it would be different. So while like let us consider here operation is manufacturing the laptop, and here you will, factory methods could be, one method will provide you the CPU, one method will provide you the monitor, one method will provide you the hard disk. Okay, so and you will have the concrete factories which are specific to the OS or the type of laptop you are manufacturing. Maybe if you are manufacturing Mac, it could be different, or if you are manufacturing a Lenovo, so whatever the requirements or the monitors it requires and what it requires for the Mac are different. Okay, so there are plenty of examples in the real world which comes under abstract factory method design pattern. So it is like factory pattern forms as a foundation for the abstract factory pattern. The only difference here is in the factory method design pattern, you have a single factory method which gives you the product. But in abstract factory, you can have multiple factory methods, okay, and those whatever the products it is providing out of the factory methods, those are grouped or those forms as a family. Okay, now let's go and see the UML diagram of the abstract factory pattern. Okay, now if you have seen in the factory method, what you have is you have a single creator and the concrete creator, and you have a single product superclass, and you will have multiple concrete products here. So here also you will have multiple concrete creators. Now if you see here, what happens is this is the interface of the abstract factory. So you will have multiple factory methods. Okay, now here if you see, you have one factory method, this is one more factory method, and in the concrete, so here what happened here is you have a single factory method, right? And even in the concrete factory, you have the implementation for a single factory method. But when it comes here, what happens is you have two products. I have defined two products, it could be more as well, and your concrete factories provides implementation for those. Okay, yeah. Now if you see here, what happens is you have two products. See, one, this interface is for the product A, and this interface is for the product B. Okay, you have product A1, product A2. Okay, this comes under the product A. Okay, and here you have product B1 and you have product B2. Now since your factory needs to, okay, you have product A and the product, it needs two products, product A and product B. Let us suppose product A1 and product B1 forms as a family. Like this is the relationship, this makes a group. Okay, product A and product A1 and product B1, and product A2 and product B2 forms as a group. Now when you are creating concrete product A1 and the product B1, and when you are creating the concrete factory 2, it should give the product A2 and the product B2. So the same thing you can see here. Okay, now if you see this one, it is giving you product A2 and the product B2. Okay, and this is giving you the product A1 and the product B1. Okay, so it's just that you have an additional factory methods, but those are all correlated. Okay, now it could be that product A1 and product B2 can form group. Okay, this can form as a combination, and you can have another concrete factory which will give you product A1 and product B2, and you can have another concrete factory which can give you product A2 on the product B1. Okay, it depends on your use case and the client. Like let's say I'm the client, and what I should do is I should create like new concrete factory A1. Okay, now when I do new concrete factory A1, when I do that, and what I can do is CFA dot create product, so product A. Okay, and when I do see a concrete factory 1 dot create product B, I'll get a product B. Okay, this way you can get products which are correlated. So in this case, what we have, so products, because product A1 and A2, these extends product A, and product B1 and product B2 extends product B. There could be scenarios as well where all products extends from the single class, but few concrete implementations form as a group. So what I mean here is, let's say you assume that you don't have this interface at all. Now you can have product A3 and you can have product A4. Likewise, you can have multiple A10 products which extends from the interface, right? Now let us assume A1 and A5 might form a combination, right? So when you do create product A should be A1, and create product B should be A5. And only this combination is a valid one. So your concrete factory should create this combination. Okay, it need not be that those form are different products. It could be similar products as well. Okay, yeah. Now let us see the pizza example what we have seen in the previous video. So what had happened is we had a stack method, right? Now let us suppose the dow it uses. Now you have a single product class. Okay, and then you have NY style pizza, NY style cheese pizza which extends pizza, and you have Chicago style clam pizza, everything, right? So now what happens is in the pizza store, while preparing the pizza, the dough they uses, maybe in the New York they uses a different dough, and in Chicago they might use a different dough. Okay, but currently what we have done is we are using a common dough for every region. Now let us suppose I create a dough abstract class, okay, or anything, it could be a super class, and what I have done is I have created NY style, New York style dough, and I can create multiple child classes like Chicago style dough. I'm creating another product interface. Okay, now here I'm creating the another one. Now what happens is when I go to pizza store, here I have a single abstract method. What I can do is I can create another abstract method. Okay, abstract dough, create dough. Okay, now it can pass the region, or I assume that it's not a parameterized. Okay, now what happens is let's go to the NY style pizza store. Okay, when you go to the NY style pizza store, currently what you have done, you have implemented only create pizza. Now what you can do is you can you have to implement other methods as well, right? So create dough. Now what I can do is I can just return new NY style dough. Okay, yeah, likewise. So if you see the pizza, what happened is I have added another abstract method here, because when you create an instance of NY pizza store, I should use only the NY style dough. Okay, likewise if you go for the other pizza stores, like if you go to the Chicago pizza store, here you should use the Chicago style dough. Okay, so the pizza and the dough are correlated here, right? So here while creating the pizza, what you can do is maybe you can pass this particular dough while creating an instance. Like while creating, you have created the dough, right? What happened is maybe while passing you can use this create dough. Okay, you can, because you have created an implementation of creator but you have not used it, maybe you can change your method. Okay, you can change your create dough of you can use, and then in the NY style cheese pizza you can form the dough. Let's go to the NY style pizza. So let us suppose I'm just going with the dough. Okay, now here instead of thin crust dough, maybe you can, what you can do is you can do this dough. Okay, so this way what you are doing is you are style pizzas. For the New York style pizzas, it should use a specific dough, and for the other style pizzas, they should use the specific dough. Okay, like you can have the same implementations like for others as well. Like I was explaining the furniture factory, so you can have multiple methods for sofa and all. Okay, yeah, let's go to the official definition of the abstract factory design pattern. Okay, now if you see here, the abstract factory method pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. So if you have seen here, you have defined an interface. These could be related because it forms as a family or it forms as a combination. And even if you see here, you are not specifying which concrete implementation it should come. Like it can be product A. Okay, it can be anything under product A. It could be product A2, product A1, product A10. You are just the your return type is product A. Okay, you are not giving any concrete return type here. And the same way for product B as well, you can create any implementation of the product B. You are not specifying a specific concrete implementation here, but the ultimate goal is you are creating a family of related objects, right? So the same thing goes here. Abstract factory pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. Yeah, the same thing we have done here. Okay. Yeah, that's it.